Well, I said in a previous video that this mill back here is just done enough to use, and we all know that's the most dangerous part of any project. Well, today we're going to install the rest of the systems to make it more convenient. CNC spindle control, mist coolant, and a pneumatic drawbar release for quick tool changes. Stick around. Welcome back to Cloud42, I'm James. If you've been following the channel for a while, you know we are in the middle of converting a Precision Matthews PM728 mill to CNC with a Masso CNC controller and ClearPath servos. And in fact, we're nearing the end of the project. It's all wired up and running, and you've even seen me use it in a recent video. But as I pointed out then, this is the most dangerous part of a project. Done enough to use. This is the point of greatest risk that I won't actually finish it. So today we're going to tick off several things that don't warrant their own videos, but that still need to be done. We'll put the spindle under CNC control, we'll add a mist coolant system, and we'll install a pneumatic drawbar release. Aside from some work holding options and maybe someday making an enclosure, that's the sum total of what I had planned for the machine. Now don't get too excited, but I might actually finish something. Before we jump in though, I'd like to thank Precision Matthews one last time for providing the mill for this project. There's a discount code down in the video description. The PM728 mill comes with a brushless DC motor and a built-in VFD to control it. Now, integrated VFDs like this are usually non-standard and they're usually difficult to interface with a CNC controller. But Precision Matthews actually sells a spindle interface board specifically for this machine. It plugs directly into the stock controller and it provides standard relay closure inputs to turn the spindle on and forward and reverse, and a standard 0 to 10 volt analog input to control the speed. Now this board replaces the direction switch and the speed knob on the front of the mill, but the latching power switch and the e-stop are still active, so you still have to power up the spindle manually in order for the Masso to control it. Now, being a manual step, there is a 100% chance that I will forget to turn it on at some point. The Masso will send the command to turn on the spindle, it won't respond, and it'll end up driving a stationary tool into the workpiece. It's pretty depressing to watch a $100 carbide tool disappear because of a simple mistake like that. So I modified the board. It turns out there's one extra screw terminal that only connects to an unpopulated pad on another connector. Maybe it's for some feature that isn't included in this version of the board, but in any case, we can use that to our advantage. I added a jumper wire and I connected the 12 volt power supply to the extra terminal, and we'll use it to feed that back to an input on the Masso so it can tell if the spindle is actually powered up. If the 12 volts is present, it's on. If the 12 volts is not present, it knows that the spindle is not on, it won't respond, and it can prevent the machine from starting. If you're a patron and you've been asking me if I will be making my connector boards available, this feature is what I've been waiting to test. I also 3D printed a mount for the board so that it won't be floating around in the cabinet, making and breaking alliances with the other wiring. This is just printed in ABS glass fiber on the Bamboo Lab H2D. It has threaded inserts to mount the PCB, and it has holes to fit existing screws that are already in the cabinet. Now there are labels printed on the silk screen of the board, but they are tiny, and we're repurposing one of the connectors, so I made my own labels to keep everything straight. And I also wired up a connector pigtail, also with heat shrink labels to make it slightly harder for me to screw it up. It's been a few months since I last looked at the wiring inside the control cabinet, so there is absolutely no way I will remember which inputs are wired to the spindle connector, which pin carries which signal, or what the color codes mean. But I planned ahead for exactly this situation, and I printed out my wiring sheet and put it in a clear pocket on the inside of the control cabinet door. Now, some people are probably going to tell me in the comments that this is a fire hazard, but so is connecting wires to the wrong terminals, so I'll take that risk. Along with my spreadsheet of input and output assignments, I also have pinouts for all of the M12 connectors, color codes for standard M12 pigtails, pinouts for the ClearPath servos, and the instruction sheets for the tool setter, the probe, and the ball screw kit. I'll keep the paper copies updated if I make temporary or permanent wiring changes, and hopefully These documents will be useful for me or any future owner of the machine. The spindle control box is pretty full, but there's a reasonably open space at the top, so that's where we'll mount the connector. I still have test prints lying all over the shop from my H2S 3D printer review, so I'll just jam this extra TPU tool tray into the box to catch the metal filings and help keep them out of the rest of the electronics. Now, you can see from your viewing angle that I'm not holding the drill even remotely perpendicular to the top of the box, but I can't see that from where I am, so I'm fine with it. I lowered the head to make this easier, but standing on something would have probably helped. I did have to remove a larger burr from one side of the hole, and watching the video, I now know why. The board with its 3D printed mount fits on the existing screws in the box, but I did have to take the heatsink and the VFD control board off the back to make enough space to get the screw out and make the connections. Like I said, it's pretty tight in here. There is a 12-volt power connector on the board that we can use to power the interface, and the front panel controls just unplug and the cable from the interface board connects in its place. All in all, it's a pretty neat installation. One thing to note is that the interface board has a single common wire for the forward and reverse circuits, while the Masso has separate common terminals for the clockwise and counterclockwise outputs. To get both clockwise and counterclockwise to work, you have to jumper the common pins together at the Masso. Now, I remember thinking about this when I was planning the project, but it never made it into the connection sheet, so I'll get a pencil and make a note for future me. Setting up the spindle in the Masso is super easy. Some might even say barely an inconvenience. The first thing I did was configure an input for the spindle motor alarm. I had to invert it so the alarm is triggered if the 12-volt power from the VFD is not present, and this prevents the Masso from coming out of e-stop if I forget to turn on the spindle power. Now, it's not perfect. The capacitors in the VFD power supply take a long time to drain when you switch it off, so if the spindle loses power during a job, it will take 10 or 20 seconds for the Masso to notice. This isn't ideal, but at least it'll protect me if I forget to turn the spindle on initially. And in a hobby shop where I don't use the machine every day, this kind of protection is really helpful. Even if it just saves me from having to hit the e-stop and re-zero my workpiece, it's a big improvement. Now, the Masso has dedicated output pins for the spindle, so there's not really much to configure. You don't have to define the outputs, they're already set up by default. You just have to set the mode, and in this case I have it set to VFD mode, and I set the maximum RPM. The Masso will then scale the 0 to 10 volt output from 0 RPM up to whatever maximum value you set. Now, I went back and forth and adjusted the number until the speed on the spindle matched the commanded speed in the Masso, at least close enough. The analog control is never going to be perfect, but it does a pretty good job from about 500 RPM up to 4,000. And I have it set so the error is a little bit on the high side. That way the chip load per tooth should never be heavier than what I expect. So if I'm running at 2,000 RPM, I might actually get 2,100, and that'll be fine. There are also some settings for the spin up and spin down delays, so it won't try to plunge into the work until it reaches the target speed. And I came back and set those after doing some testing. Now, as a side note, the spindle speed display on the control box is no longer working after connecting up the Masso. I checked the wiring and I tried adjusting the optical pickup, but it's still wonky. I don't really need it, but it would be nice to have just to confirm that the spindle control is working properly. I'm going to keep moving right now, though, because I really don't have time to stop and troubleshoot it. Maybe I'll come back to that later. Or maybe somebody will see that and leave me a comment telling me what's wrong. One can hope. When I designed the accessory plate to hold everything on the back of the mill in a previous video, I also included a mount point for the mist cooling system. This is the dual nozzle fog buster that I had on my Grizzly mill. I pulled it off before selling it because I knew I wanted to use it here. Now, this thing sat for a long time unused on the Grizzly mill, and it's been sitting on a shelf since I sold that mill, and this soluble oil has been sitting in the tank and the tubing the whole time. It smells okay, but it has definitely started to separate, and there's some dark solid bits visible in the tubing. I don't know what they are, but I'm gonna have to clean them out. I already have an air valve on the mill connected to a relay output and configured in the Masso, so I can just hook up an air line and we should be good to go. When I mounted the fog buster on the Grizzly mill, I was actually making a spindle mount, so it was easy to just drill and tap some holes for the nozzles to mount to. I really don't want to drill and tap new holes in this machine though. Fortunately, there is a convenient cover plate on the bottom of the quill, held in place with 3 screws. It looks to be just a piece of powder-coated 3mm steel plate. There's no seal, and the bearings don't make contact with it, so this seems like a reasonable place to attach the mist nozzles. So I sketched up a replacement plate with the same mounting holes and sent it off to Send Cut Send. They laser cut it out a mild steel sheet, bent it to my specification, inserted PEM nuts where I want to mount the nozzles, and powder coated it gloss black. Now, Send Cut Send supports the channel by providing parts for my projects like this one, and there is a discount link in the video description. I measured the center hole in the original plate, and I sized the new one with a small allowance to account for the thickness of the powder coat. I must have measured it correctly because it seems to fit. I did do a 3D printed prototype so that I could test before sending off the order, but I of course had to wait for the real part to confirm the powder coat thickness. They specify it on the website, and I put that in the design and compensated for it, and it looks like it turned out pretty well. It's a close fit to keep debris out of the bearings, but I can't feel any drag, so I think we're good. I also designed and 3D printed these clamp mounts to hold the 1/2-inch lock lines that support the nozzles. And these are printed in my favorite ABS glass fiber in blue to match the blue paint on the mill. They attach to the bracket with 2 M5 screws each, and this puts the nozzles right where they need to be to apply mist to the cutting tool. I took a little material off the surfaces of the blocks where they come together so that they will squeeze down on the lock line when I tighten the screws and hold it securely. In the Masso, there is only a button for flood coolant. The Masso has the concept of mist coolant, but there's no button for it, and there's no way to configure the user interface to change it as far as I can tell. So I reluctantly configured the air valve on the fog buster as flood coolant. It isn't ideal because my G-code will have to call for flood coolant when it's really mist, but I'll just live with it. Now that I'm thinking about it, I could probably put another relay on there and parallel it up so that it activates the same valve, so no matter what you select, it'll select the mist coolant. But this is one of those situations where the simplicity of the Masso makes it come up a little bit short. It's not a big deal, but it's one more thing that I have to remember. Now, I thought I would be able to just open the valve and clear out the tubing, but the solid chunks of whatever it is ended up being a real problem. I ultimately had to disconnect the tubes at both ends, pull the needle valves completely out of the metering blocks, and just blow everything out with compressed air to get it all working. I'm going to attempt to run these at really low pressure, like below 10 psi, to try to keep from blowing chips all over the shop, but we'll see how well that actually works. Now, you and I both know that I'll end up making an enclosure at some point, but just let me pretend for a little bit longer. I'm planning to use this mill with the Tormach tooling system, which uses a shortened 3/4 inch collet and tool holders with 3/4 inch shanks. This, in combination with a tool setter, makes it really easy to change tools while running a CNC job, and it also makes it possible to build an automatic tool changer if I want to do that at some point. The one thing that's missing, though, is a quick way to swap the tools. You can swap the tools with an electric ratchet, but it requires 3 hands, and since I don't have 3 hands, I always end up dropping expensive tools and breaking them over and over again, which gets very expensive very quickly. Now, the solution, of course, is a pneumatic drawbar release. The idea is that the drawbar is installed with a stack of Belleville spring washers, and there's a pneumatic cylinder that compresses the washers to open the collet and release the tool. Now, I was originally planning on designing and building my own pneumatic drawbar. I actually have a used Tormach cylinder that was sent into the channel by Dale at WidgetWorks Manufacturing. Thank you, Dale. And I had grand plans to use it in my own design. I was trying to find a source for the cylinders so that if anybody else wanted to use my design, they could buy the parts, but I did not end up getting that far. Unfortunately, I discovered very late in the design process that this cylinder is way too big to fit on the PM728. I could technically get it partially over the drawbar and it might work, but it actually makes contact with the motor, which still has to be able to move to tension the belt. It's also comedy sized for this mill and very, very heavy. So I reached out to Greg at Priest Tools because he sells some smaller multi-stage pneumatic cylinders that would be a better fit. Now, of course, he sells those cylinders because he makes a drawbar kit for this machine. And as soon as he heard what I was trying to do, he offered to just send me one of his kits. So that's what we're going to install today. I kind of wanted to design my own, but I also kind of want to get this machine running. And if you look around the internet, the Priest Tools kit is the one that you will find for this machine, so I figured people would be interested in seeing how it works. The Priest Tools kit comes with all of the hardware and pneumatic components, as well as a complete wiring harness with a toggle switch and a valve. Now, I'm not actually planning to use the electronics because I already have pneumatic valves on the mill, and I want to control everything with a foot pedal and the Masso CNC controller. The Masso has a spindle lockout on the unclamp circuit, so it can prevent the drawbar from being released while the spindle is turning, and that's something that will help avoid accidents. Greg sent me the version of the kit that has a 4-stage pneumatic cylinder. Now, the more stages the cylinder has, the more total force it can generate, and the more torque you can put on the drawbar and still expect the cylinder to release it. Now, I'm super paranoid about tools pulling out of the collet after a couple of bad experiences with the Grizzly mill, so I want as much torque on the drawbar as I can reasonably get. Now, in theory, the system will work fine with less torque, but I kind of feel like anything worth doing is worth overdoing, and since I only have 90 psi shop air at the moment, I want all the force I can get. Now, the kit also comes with a new drawbar to accommodate the stack of Belleville spring washers, also included in the kit. The pneumatic fittings that came with the kit have sealer pre-applied, but I never trust that stuff, and so I'm going to add more. I use this T+2 thread sealer on every pneumatic fitting I assemble, and I have yet to have one leak. I think it's easier to apply than Teflon tape, and you don't end up with little strings of tape going down all the air passages and causing problems in the future. Air applied to the top inlet of the cylinder extends the cylinder to compress the springs and release the drawbar, and air applied to the bottom inlet raises the piston back up to its rest position so that it isn't making contact with the end of the drawbar. Now, the instructions say to install these support screws in the bottom of the plate first, but just ignore that. It is easier to mount the cylinder on the plate first and then install the support screws just before mounting it on the machine. The system also has a small forked plate that can be slid in and out to engage and disengage from the drawbar collar so you can use the quill without it being in the way. Anti-seize is required on the outside of the Tormach collet to allow it to clamp and release easily. I didn't put enough on initially because I was afraid of getting too much, and the drawbar had trouble releasing, so I added more. You just have to be really careful not to get any in the slots or on the inside of the collet, or the tools will slip. The new drawbar goes into the spindle with a stack of Belleville washers and a flange, and it can be tightened down to whatever torque you need as long as you have the cylinder stages and shop air pressure sufficient to release it. I tightened the drawbar 10 flats or 10/6 of a turn, which should give me about 25 foot-pounds of torque, and it should release reliably on 90 psi shop air. Now, it's easy to adjust later if that's too much. I don't know, we'll have to see. The cylinder is mounted with 2 screws that are free to slide in the plate and 2 that just sit on top of the head. This allows the whole cylinder to float up and down, so it's pulling up on the collar under the Belleville washers, putting all of the force into compressing the springs and not into the spindle bearings. The usual approach with a double-acting cylinder like this is to use a single valve that routes air to one side of the piston or the other, and in fact that's exactly what was included with the wiring harness in the kit. Now the benefit of this is that it's really simple. The cylinder is always either extending or retracting, and you only need one valve. One side is always under pressure. Instead of doing that though, I am using two valves that are connected to the two sides of a single relay. So only one valve is energized at a time. Now this gets exactly the same result in practice, but the benefit is that both valves shut off when the machine is powered down. So I don't always have shop air pressure to the bottom of the cylinder, and a slow leak won't make my compressor cycle. A leak in the cylinder will only leak when the machine is on, and I can live with that. I have a foot pedal connected to the Masso and configured as the spindle unclamp input, and then the cylinder valve is configured as the spindle unclamp output. Pressing the pedal activates the cylinder, releasing the tool, and releasing the pedal retracts the cylinder, allowing the spring washers to reclamp the tool. You just have to be careful to never release the pedal without a tool in the spindle, because it can overcompress the collet and potentially damage it. Now, one disadvantage of using a pedal for this instead of a toggle switch is that I can't just leave the collet open. But that's probably fine because the Masso actually keeps track of which tool is in the spindle, even across power cycles, and they tell you never to change the tool without being asked to do so. It's assuming that the tool will stay in the spindle until you put a different tool in the spindle. Now, if you really do need to take all of the tools out, the Drawbar kit does come with a 3/4 inch pin that you can put into the collet just to protect it. Now, the Masso interlocks the unclamp signal with the spindle speed control, so in theory, it won't let you engage the drawbar cylinder while the spindle is turning. Now, I was terrified to actually test this, but it's gonna happen sooner or later anyway, so it's better to test it now when I'm expecting problems just to be sure. Now, I may or may not have disconnected the air lines and tested it off camera just to make sure it wasn't gonna explode, but it seems to work. As long as the spindle is turning, the pedal does nothing, and when the spindle is stopped, it works normally. Now, the collet does seem to stick in the spindle taper sometimes and fail to release. It usually does this the first time it's released after the machine's been sitting for a while, and I think it's probably just a matter of adjusting the drawbar tension, the air pressure, and the amount of anti-seize on the taper. I've also heard that burnishing the taper or just letting it burnish over time will also make that better. Well, I think this machine is now pretty much ready to run, and I have a few projects lined up to use it. In particular, the combination of the power drawbar, the tool setter, and the spindle control should make complex programs with multiple tools much easier to manage. Now, the 4-inch vise that's on there at the moment eats up a lot of Y travel, so I am planning on installing a fixture plate with some more flexible work holding options, so stay tuned for that in a future video. If you enjoyed this series or found it useful, give it a thumbs up. Feel free to subscribe and maybe think about supporting the channel over on Patreon. Patrons can download the CAD files for this and all of my other projects. Thank you for watching.